Dear students, welcome to today's session of Database Management System, and the topic of the session is Relational Model. The course outcome of this unit is to convert the ER diagram to Relational Database Schema. So you might have known how to draw ER diagram for any given database. So from that we are going to design or produce Relational Database Schema. At the end of the session, you will be able to explain about the relational model and the structure of the relational databases. First of all, what is a data model? It is a collection of conceptual tools and for describing the data, the relationship between the data semantics, and the consistency constraints. We have four such data models: relational data model, entity relationship model, object-based data model, and the semi-structured data model, out of which we are going to discuss about the relational model in this session. A relational model uses a collection of tables to represent both the data and the relationship among the data. So we are going to have several data tables, and you have data which is put on stored in that table, and for each of this table we have multiple columns, and each of these columns will have unique name. The tables are also called as relations in a relational model, and the relational model is an example of record-based model, and hence relations are also called as records. The columns of the table correspond to the attributes of the record type which we have designed in the ER diagram. So we have entities for which we have the attributes that are produced as columns in these tables. About the relational model, today a vast variety of database products are based on this relational model, and this has attained this primary position because of its simplicity, and hence the programmer's job will be very easy compared to the other data models like the network model and the hierarchical model. The relational model describes data at the logical and the view level, and hence abstracting away the low level details of the data storage. The low level details or the implementation details are hidden from the user, and hence it is more easier for the programmer. So this describes the data at the logical and the view level only. And in this relational model, several issues has to be addressed. Like the most important issue is how user specifies request for retrieving and updating the data. We have several query language for this. So one issue is that we have to decide on how user can request for retrieving and updating the data. So this can be addressed like you can have query languages for doing this task. The second one is that the issue is data integrity and protection of the data which is stored in the database has to be protected. The databases need to protect data from damage by the user actions, which can be either intentional or unintentional. For doing this, we have to have some things. Now we'll discuss how the structure of the relational databases look like. So this is an example for a relational database. We know that a relational database is a collection of tables, and each of these tables is assigned a unique name. So the relational database is a collection of several tables, and each of these tables will have a unique name, table itself. For example, instructor is a table. So that is the table which stores the details of the instructor. Like here we have ID, name, department name, and salary. So these are the attributes of the entity instructor in the ER diagram. So that has been designed as table in the relational database. Each instructor is identified by the value of the column ID. So each of these instructors will be identified by the ID which has been allocated for that particular instructor. A row in a table represents a relationship among a set of values. Since a table is a collection of such relationship, there is a close correspondence between the concept of table and the mathematical relations, from which this relational model has taken its name. A tuple is a sequence of values or a list of values. A tuple is a list of values. A relationship between n values is represented mathematically by an n tuple of values. That is a tuple of n values which corresponds to a row in a table. So simply you could remember that a tuple is a row in a table. In the relational model, the term relation is used to refer to a table. Since we are addressing the relational model, we have to refer this table as relations, and the tuples refer to the row, and the attributes refer to the column of the table. So we have tables, the rows corresponds to the tuples and the columns corresponds to the attributes. Relation instance refers to specific instance of the relation at a particular point in time. So that is relation instance. The order in which the tuples appear in the relation is irrelevant. We need not worry about the order in which the tuples appear in the relation, and also the order in which the columns appear in the relation is also irrelevant. We need not worry about that. For each attribute of a relation, there is a set of permitted values called as domain. For example, if you have a gender attribute, then you have a set of permissible values which are male and female. So that forms the domain of that particular attribute. So for every attribute, you will have a domain from which all possible values will be provided. For example, the name attribute is having the set of all possible instructor names of the organization. A domain is atomic if elements of the domain are considered to be indivisible units. So you should not be able to divide. You cannot divide male or female further. So that is what called as atomic domains. If we split the value for the phone number attribute into a country code, area code and local number, we would be treating it as a non-atomic value. So if you consider phone number as a single indivisible unit, then it is said to be atomic. Instead, if you could split that phone number into country code, area code and local number, then it would not be considered as a atomic value. It will be a non-atomic value. So a domain has to be atomic, and if the elements of the domain are indivisible. Null. The null value is a special value that signifies that the value is unknown or does not exist. So this null plays a major role in most of the database activities. Suppose that we include the attribute phone number in the instructor relation. So we have the relation before which we have not introduced the phone number attribute. Suppose that we are going to include this attribute. It may be the case that an instructor does not have phone number at all, or that the telephone number is unlisted. He might not have any phone number, or his phone number may not be listed. We would then have to use the null value to signify that the value is unknown or does not exist. So we cannot leave any columns as empty. That's why we have to insert null value to indicate that there is no phone number or the phone number is unlisted. And the null values cause a number of difficulties when we access or update the database, and thus this should be eliminated if at all possible. The next is database schema. Database schema is the logical design of the database. The schema refers to the logical design of the database, and the database instance is a snapshot of the data in the database at any given instance in time. At a particular instance in time, you may have 10 tuples or 5 tuples, and at that particular point in time, what is the snapshot of the data? That you call it as the database instance. And the relation corresponds to the programming language notion of variables. So the relation in database is similar to variable, and the relation schema corresponds to the type definition. So for example, int a, here a is the variable which corresponds to the relation that can hold the data. So that is the table here, and the relation schema is the format or the design. So that is equal to the type definition of the variable. Relation instance corresponds to the value of the variable. The value of the variable, as you all know, it might be changing during the execution of the program. Similarly, the instance of the relation keeps on changing during the working of the database. So this is best explained with the help of variable. So relation corresponds to the variable which can hold the data, and schema corresponds to the type definition, which is the design, and the instance refers to the value which can change during the execution of the program. The value of a given variable may change with time. Similarly, the contents of the relation instance may change with the time. But the schema cannot change. The value of a variable can change, but the data type cannot change. So this is the explanation or correspondence of the schema and the variable. A relation schema consists of a list of attributes and their domain. So here is a relation and a schema. So this is the relation. This is a department relation where you have department name, building and budget. So when you convert this as a schema, you have the name of the relation here and together with the attributes which are listed. So this is a university database example. We are talking about mostly the instructor, student, etc. So all these are the relations. Relations are the tables. So we have a table for section under which you have the attributes, which are the columns of this particular table, and you have a teachers table, instructor table, student table, course table, advisor, take, classroom, time slot. All these are the records or the tables of this particular database. So this university database consists of some 5 to 10 tables, and each of these tables have some specified attributes. So for all these things we have to get the data from the user and store it in the database. Summary: we have introduced the relational model and what are all the issues to be addressed when going for this relational model, and we have discussed the structure of the relational databases, out of which we have discussed about the schema, relation schema, and the university database sample. So this is the reference book. Thanks for your patient listening.